We start A2 with the modulus function, and you must have seen these two lines coming at least somewhere, right? And that two lines, those are straight lines around a number that represents the modulus of that number, where the modulus of a number, which is also known as the absolute value, is the positive value of a number. Meaning what? If I have the modulus of a normal number, that's going to be the positive value of that. And if I have the absolute value of a negative number, it's also going to be the positive value of that. And that is what the modulus is. And a more general definition of the modulus is this. The modulus of x is defined as this is x if x is greater or equal to 0, means if x is positive. So if the number inside is positive, then the modulus is the number itself. While if the number is negative, then the modulus will be negative times that negative number, which means you're going to get a positive as well. So both of these are positive values of that number that is inside. Look at an example. Suppose we have x, -2, -1, 0, 1, and 2, and the modulus of that, -2 will be the positive version of that, which is 2, -1 positive version of that, which is 1, 0 is just 0, 1 is already positive, so that's going to be 1 as well, and 2 is already positive, so that's going to be 2 as well, which gives us this thing right here, where when x is less than 0, which is from -2 up to 0 but not including 0, you have the graph of negative x, which is this right here, up to but not including 0. And on the positive side, you have the graph of y equals to x, which is from 0 included up to positive infinity. And that's how the general modulus function would look like. Next, we are told to sketch the following modulus functions, where firstly we are given y equals to modulus of x minus 3. So here obviously we can have the thing inside to be negative certain times, and we can have the thing inside to be positive at other times, depending on what the value of x is. If x is less than 3, then the value inside these two lines, these modulus lines, will be negative. And if the value inside is negative, then we want to multiply it again by a negative so that we get the positive value of that function. So when x is less than 3, this y equals to the absolute value of x minus 3 will look like negative x minus 3. Because when x is 0, 0 minus 3 is going to be negative 3. And you want to have the positive version of negative 3, which is going to be positive 3. So you're going to multiply it by a negative. On the other hand, when x is going to be greater or equal to 3, where the function inside these straight lines, the modulus function, is going to be positive in itself, then we don't have to make any changes to it. And so our function is going to be x minus 3. And that's how the function will look. So negative of x minus 3 when x is less than 3, and x minus 3 as it is when x is greater or equal to 3. Then here, same thing happens, because remember, the sign changes when the content of this modulus changes. So if the content inside is negative, then you want to multiply by a negative again so that you get a positive. And when the content inside is a positive, then you leave it as it is, as a positive. So what's going to happen here again? We're going to have two versions. One when x is less than 3, where we get the insides to be negative. We're going to multiply that by a negative, so we get the positive version of that. And we're going to leave the rest as it is. On the other hand, we have when x is greater or equal to 3, so the inside here will be positive as it is. So we're going to leave it as it is. So x minus 3 minus 2. And this right here is just going to be negative x plus 3 minus 2, which is going to be negative x plus 1. And on this side, it's going to look like x minus 5. So that's going to be the function when x is greater or equal to 3. And that is going to be the function when x is less than 3. And obviously, we can rewrite this as well as 3 minus x. Then we look at C, where firstly, we need to find what that x value is such that any value lesser than that will give us a negative inside the modulus, and any value greater than that will give us a positive inside the modulus. So we want to check for 2x plus 8 for it being greater or equal to 0. And after solving this, we get 2x greater or equal to negative 8 and x greater or equal to negative 4. That means when x is greater or equal to negative 4, this thing inside the modulus is positive, and so the function is going to be as it is. So 2x plus 8, that's how the function will look like. On the other hand, when x is lesser than negative 4, the value inside the modulus will be negative, and so we'll need to multiply it by a negative again to get the positive value of that function. Because remember, we want the absolute value, which is the absolute positive value of whatever is inside those two straight lines. So you want to multiply it by a negative. So negative 2x plus 8, because remember, this 2x plus 8 is now going to be a negative value. So you want to multiply it by a negative again to get a positive. And that's going to look like negative 2x minus 8. And you can do the same thing here for 8 minus 2x. You need to find the x that would give us greater than 0. So 8 minus 2x greater or equal to 0. Solving that will give us 8 greater or equal to 2x over 2x is lesser or equal to 4. So when x is lesser or equal to 4, we get this thing inside to be positive, which means the function will remain as it is, 8 minus 2x. Obviously y equals to 8 minus 2x. And when x is greater than 4, it's going to look like negative of 8 minus 2x, because this 8 minus 2x will be a negative value in itself. So we want to multiply it by negative again to get a positive value. So it's going to look like 2x minus 8. Next, we are told to sketch the following modulus function. So for that, we need to know exactly what the functions look like, right? In terms of equations. So firstly, we want to find the values for which this 5x minus 8 is going to be positive in itself, and when it's going to be negative. So for that, we let 5x minus 8 greater or equal to 0 and solve for that. So 5x greater or equal to 8 over 5, x is greater or equal to 1.6. Therefore, when x is greater or equal to 1.6, 5x minus 8 is positive in itself. So we leave it as it is. So that's going to be the equation. When x is lesser than 1.6, the inside 5x minus 8 will be a negative value in itself, which means we want to multiply it by a negative again in order to get a positive value of that function. So it will become negative times that 5x minus 8, which will look like 8 minus 5x. So our graph will look like this for all the values less than 1.6, and our graph will look like this for all the values greater than 1.6, greater or equal to 1.6. So we're going to draw our grid. We have our value at 1.6. And remember, at 1.6, our value will be 0, or y will be 0. And this follows from 5x minus 8, so it will look something like this. Obviously, we don't have anything at the bottom. We only have the top part of it. And on the other side, 8 minus 5x. So obviously, this is at 8. Remember, this is at negative 8 because that's the y-intercept for either one. And you get something like this, where obviously the bottom half is imaginary. And that's going to be how this function looks like. Next up, let's look at b, where again, we need to find the place where x plus 3 will be positive and where x plus 3 will be negative. This is quite easy. So when x is greater or equal to negative 3, the value inside will be positive. And so this is going to be as it is, right? So the entire function will just be 6 minus, as it is here, x plus 3, which is going to look like 6 minus 3, which is 3 minus x. So that's going to be the equation when x is greater or equal to negative 3. When x is lesser than negative 3, the value inside will be negative, and so we want to multiply it by another negative in order to get the contents to be positive. So we will be doing what? 6 minus negative of x plus 3, which is 6 minus negative x minus 3, which is just 6 plus x plus 3, which is just 9 plus x. And that's going to be the equation for x is less than negative 3. And sketching this, you draw your grid where you have your negative 3 point. And before that, your graph will be 9 plus x, which is going to look something like this, where this value is 6 and this value is 9, which is the intercept of what this curve will look like. And then when x is greater or equal to -3, you're going to have 3 minus x, where it starts from 3 and it goes upwards like this. Obviously, the rest of it is going to be imaginary. This goes on forever. And that's how this graph would look like for this modulus function. Finally, we look at C, where again, we start off by finding the values for which 5 minus 2x is positive. So 5 minus 2x greater or equal to 0. 5 greater or equal to 2x over 2 over 2. This is when x is less or equal to 2.5. So when x is less or equal to 2.5, this value inside is going to be greater or equal to 0, which means you're going to leave it as it is. So we're going to leave the entire function as y equals to 3 minus, as it is, 5 minus 2x. Okay, so 3 minus 5 plus 2x, which is just -2 plus 2x. On the other hand, when x is greater than 2.5, this value inside is going to be negative. And so we're going to multiply that entire thing by a negative to make it a positive, because again, it is the modulus function. So we want to make everything positive. So we're going to get 3 minus negative of whatever is there. And then you get 3 minus -5 plus 2x, which is just going to be 3 minus -5, which is 8 minus 2x. And that's going to be the function when x is greater than 2.5. So now we're going to draw that and sketch it, where our turning point is obviously 2.5, where it changes. And at that point, our value is going to be 3, as it is. And for when it's lesser or equal to 2.5, our equation is going to look something like this. So from -2 is the intercept, as we see here, and it's going to look something like this. And obviously the rest of it is going to be imaginary. It will intersect the x-axis at 1. When x is greater than 2.5, it's going to look something like this. So this is going to be proper, and the one before that is going to be imaginary. And obviously it will intersect at 8, because that's the y-intercept. And the x-intercept will be at 4. So this is your y equals to 8 minus 2x. And this left part is your y equals to -2 plus 2x. And that's going to be how this graph will look like. We move on to another example, and this is a bit of a weird one. And the reason why is because we have two modulus functions, okay? And what we want to do is we want to look for the value of x individually for both of these, which would give the negative value inside the modulus for each of them. And obviously what will give you the positive value inside the modulus. So we start off with this x plus 1. And obviously when x is greater or equal to -1, then the value inside this modulus will be positive. And when x is lesser than -1, the value inside this will be negative. And when you go to the other modulus function, we get that when x is lesser than or equal to 1, we get whatever is inside here to be positive. And when x is greater than 1, we get whatever is inside here to be negative. And what we can do here is draw a number line which has all of these areas. So we have -1 and we have 1 right here. Okay, and I'm going to name this as our first modulus, and we're going to name this as our second modulus. Okay, when our x is, obviously this is the x number line. When our x is greater than 1, we are looking at the first modulus function being positive, yes, and the second modulus function being negative. When you look at between -1 and 1, you get that both the first and the second are both going to be positive. And when you look at less than -1, we get that the first one is going to be negative while the second one is going to be positive. And what this does is we can split now not into 2, but we can split the function into 3. So when x is lesser than -1, we have the first one being negative, so we're going to apply a negative to it to make it a positive. So negative of x plus 1, plus the second one is going to be positive, so we're going to leave it as it is, 1 minus x. When x is between -1 and 1, inclusive, because both of them are inclusive, we're going to have something like this. So x is greater or equal to -1 and less than or equal to 1. Then we have both of them being positive. That means it's going to stay as it is for both of them, x plus 1 plus 1 minus x. And when x is greater than 1, then we have the first one being positive, so it remains as it is, x plus 1. And the second one becomes negative, so we change the sign here. So plus negative 1 minus x. Rewriting all of this, we get negative x minus x, which is negative 2x, and negative 1 plus 1, which is 0. So when x is less than -1, we just get negative 2x. When x is between -1 and 1 inclusive, we can see that the x and the negative x cancel out. We just get 1 plus 1, which is just 2. And when x is greater than 1, we get x minus x, which is x plus x, which is 2x. Then here we get 1 minus 1, which is 0. So here we just get it as 2x. And that is going to be the way our graph is going to be. And in order to sketch it, we can do it right now. So we can draw our coordinate plane. And we have our two main points, the -1 and +1. Remember, between them, we're just going to be at 2. Just going to be at 2. And then when x is greater than 1, our function is going to be 2x. So it's going to look something like this. Obviously passing through the origin, imaginary. And when x is less than -1, it's going to be negative 2x. Again, passing through the origin, imaginary. And this is how our function will look like, this function right here. After accounting for all the sections where this function is going to change its signs. We can do the same thing for the next one. Again, we know that the sections are -1 and 1, right? Because these are the same modulus functions. And so we can draw our number line again. Again, I'm going to name this as our first and I'm going to name this as our second. And we have -1 and we have +1. Anywhere before -1, so any x value which is less than -1, our first one is going to be negative and our second one is going to be positive. Anywhere between -1 and +1, our first one is going to be positive and our second one is also going to be positive. Then anywhere from 1 onwards, our first one is going to be positive and our second one is going to be negative. And so when x is less than -1, our function is going to be negative for the first one, so negative of negative x plus 1, plus positive for the second one, which is just 1 minus x. Then when x is between 1 and -1, both of them are positive, so it's going to stay as it is. So negative x plus 1 plus 1 minus x. And when x is greater than 1, we get the first one being positive, so we leave it as it is. So negative x plus 1. The second one is going to switch to negative. So plus negative 1 minus x. And we end up getting, for x is less than -1, we get negative of negative, so this remains as it is. So just x plus 1 plus 1 minus x, which is just going to be 2. And then for x between 1 and -1 inclusive, we will get negative x minus x, which is negative 2x, and negative 1 plus 1, which is 0. So we get just negative 2x. And for x greater than 1, we get negative x plus x, which is 0, and negative 1 minus 1, which is negative 2. So we're going to get, for x is greater than 1, we get it as negative 2. And here what we can do now is draw this function right here. So we start off by drawing our xy plane. Our important values -1 and 1. Everywhere before -1, we have our values at 2. Everywhere after +1, we have our values at -2. And between them, we have a line with the gradient of -2x, which, if you want to draw it, is going to look something like this, passing through the origin. And at -1, it's going to be at +2. and at positive 1 is going to be at negative 2. And that's how this equation will look graphically. Now on to solving equations involving a modulus function. So we have three methods. The first one is graphical. So you can draw this graph and how it looks like. I'm going to draw this right now. And this is going to be the graph of the modulus of 3x minus 5. And you want to equate it to 4, so we draw the line at 4. And if you draw it obviously on a graph paper, you'll be able to see where they intersect. And that will be at when x is 3 and when x is 1 over 3. And so those two will be your answer, x equals to 3 and x equals to 1 over 3. The second way is by using the fact of the positive and the negative. So here we basically have what? The 3x minus 5 equals to positive 4 as our first option. And remember, because it's a modulus, we can have the other option as 3x minus 5 equals to negative 4. Because what the modulus does is it changes both the positive and the negative into just a positive, right? So this one basically what it tells you that the distance from 3x minus 5 is 4. So remember, you can have a positive distance, so you're going positive 4, or you can have a negative distance where you're going negative 4. 3x minus 5. So it can equal any of these, right? Because when 3x minus 5 is negative 4, if inside here is negative 4, the modulus of that will be positive 4, right? And so we can solve both of these. We get 3x equals 9, which gives us x equals 3. And we also get 3x minus 5 equals negative 4. 3x equals 1, which gives us that x is 1 over 3. And so you get both the same answers using the two signs method. The last method is by squaring both sides. So remember, because of the negative and positive, if you just square both sides, you're going to get rid of that problem, right? So we can square both sides. Here we get 9x squared minus 30x plus 25 equals to 16. Rewriting this, we get 9x squared minus 30x plus 9 equals 0. And solving this equation quadratically, we will again get x equals to 3 and x equals to 1 over 3. So we're going to use the second method because I think that's the easiest one. We can just equate each of these where the first one is going to be with a positive 3, the second one is going to be with a negative 3. And so because remember, 2x minus 1, if it is negative 3, then we'll basically have this, which is equal to positive 3. Yeah? So 2x minus 1 equals to 3, 2x minus 1 equals negative 3. Here we'll get 2x equals 4, which gives us that x equals 2 from this. And here we will get that 2x equals negative 2, which gives us that x equals negative 1. Okay, for the second one, again, same thing. 4 minus 7x equals 10. 4 minus 7x equals negative 10. Again, here you can take 4 to the right. We get 10 minus 4, which is 6. So negative 7x equals 6 over negative 7 over negative 7. X equals negative 6 over 7. Or the second one, negative 10 minus 4, which is just negative 14. So negative 7x equals negative 14 over negative 7 over negative 7. We get that x equals 2. So x equals 2 or x equals negative 6 over 7. For the next one, this is slightly different. And the reason for that is, remember, it's the modulus that can change the sign, right? So here we can't just apply the negative on the right. But what we can do if we want to do that is we can shift this entire thing to the right side to make it a positive modulus and take this to the left. And so we get 2 plus 8, which is 10, equals to 2x minus 9. Then we can solve one normal way. So 2x minus 9 equals to 10 and 2x minus 9 equals to negative 10. We can solve both of these. We get 2x equals to 19. Divided by 2 divided by 2, we get that x equals 9.5. And here 2x will equal to negative 1. Divided by 2 divided by 2, we'll get that x equals to negative 0.5. And here we get two answers as well. Now what if you can't do that? And we will see that in part D. So what we do here, remember, this modulus function has two parts to it. One is the positive value of the modulus function, and one is the negative value of the modulus function. And that's exactly what we do here but we just shift that sign onto the other side. Yeah, and we can do that. If we divide by -1 for this, we can just shift the sign to the other side. So here what we will do is we won't shift it, we'll just keep the sign here. So the first way is when it's positive, so just x minus 4 equals to 2x plus 1, quite simple. The second one is when we will apply the negative multiplication to the x minus 4. So negative of x minus 4 equals to 2x plus 1, which is just 4 minus x equals to 2x plus 1. The first one will give us, if we take x there, we get 2x minus x, which is x. And 1 to the other side, we will get -4 minus 1, which is -5. So x equals -5. For the second one, we will take x to the other side, we will get 2x plus x, which is 3x. And 1 to the other side, we will get 4 minus 1, which is 3. So 3 equals 3x, which gives us that x equals 1. And so you solve for all of them here. Next up, we have questions like this, which have more than one modulus functions, right? So this one, for example, has 3x plus 4 and x plus 5. Now, in this type, because there is no other number, what we can do to eliminate the moduluses, remember the third method, you can just square both sides, right? And if you square both sides, square the left, you get 9x squared plus 24x plus 16 equals to x squared plus 10x plus 25. Then you rewrite this, you get 8x squared plus 14x minus 9 equals 0. Then you can solve this, and that will give you your answer. And here I get x1 being a half, and x2 being negative 2.25. Those are going to be my two answers for the first one. In the second one, you see there is something else that's there. And when it comes to these type of questions, try and draw a number line and see the possible scenarios that are there. So firstly, remember number line the way we did it before, where you check what values of x will give you a positive for this. So 2x plus 3 greater or equal to 0, where 2x greater or equal to -3, x is greater or equal to -3/2. Okay, that will give us our 2x plus 3 as 2x plus 3, and x less than -3/2 will give us -2x plus 3. Okay, then on the other hand, we have our x minus 5, where x, when it's greater or equal to 5, we get positive inside, so we leave it as x minus 5. And when x is lesser than 5, we get the inside as negative, so negative of x minus 5, which is just 5 minus x. Then you can draw your number line, where you have your 5 and you have your -1.5, okay, which is -3/2. And when both of them are greater, yeah, you have 2x plus 3 and x minus 5. So you have 2x plus 3 and x minus 5. In the middle, you have 2x plus 3, but it's less than 5, so you have 5 minus x. And on the left, you again have 5 minus x, and you have -2x minus 3. And so we want these scenarios that are there, right? So the first scenario is -2x minus 3 equals to 5 minus x plus 3, and solve that. Then you want 2x plus 3 equals to 5 minus x plus 3 for the second one. The third one, you want 2x plus 3 equals x minus 5 plus 3, and you solve each of them. Solving this one will give us x equals -11. Solving this one will give us x equals 5/3. And solving this will give us x equals -5. And then you go back and check. Remember the first one we got for this interval right here. And does this -11 lie in that interval? Yes, it's less than -1.5. Then in the second one, which we looked at the second interval from -1.5 to 5, and we got this as our answer, then we check, does x equals 5/3 lie within this interval? We get a yes as well. And for the last one, we got the interval of greater than 5, and the answer we got was -5. And does -5 lie in this interval? No, it doesn't, right? So the only two answers will be x equals -11 and x equals 5/3. Moving on to C, we do the same thing again. So we have x plus 3, and when x is greater or equal to -3, we get x plus 3 to be x plus 3. And when x is lesser than negative 3, we get it as negative x minus 3. And on the other side, when x is greater or equal to negative 5, we get it as x plus 5. And when x is lesser than negative 5, we get it as negative x minus 5. And so we can draw our number line right here, where this is negative 3, this is negative 5, and you write for each. So when you have it greater or equal to negative 3, we have this as x plus 3, and we have this as x plus 5. When it's greater than negative 5 but less than negative 3, we get it as negative x minus 3 but still x plus 5. And on the left, we get both of them as negative, negative x minus 3 and negative x minus 5. Then we look at these three cases. So the first one, when it's less than negative 5, we get negative x minus 3 minus x minus 5 equals 10. That's for this range here. Then for the second range between negative 5 and negative 3, we get negative x minus 3 plus x plus 5 equals 10. Then in the third one right here, we get that x plus 3 plus x plus 5 equals 10. And we're going to check for each of them. The first one, your x you'll get is equal to negative 9. The second one, the x and x cancel out, and you just have 2 equals 10, which is not possible, so this will be eliminated. And in the third one, you get that x equals to 1. And do these now lie within their ranges respectively? So x negative 9, does it lie within the less than negative 5 range? Yes. So this is going to be one of your answers. And x equals to 1, does that lie in your range that you used it in? Yes, because it's greater or equal to negative 3. So both of these will be your answer, negative 9 and 1. This one is not part of the answers because, first of all, you don't even have an x to solve, right? The x cancels each other out. So these two will be your answers. For the final one, again, you start looking at the first one. And when x is greater or equal to negative 1, inside here will be positive. And so we're going to leave it as x plus 1. When x is lesser than negative 1, we get the insides as negative, so you want to multiply the whole thing by negative again, so it becomes positive, so negative x minus 1. Then you look at the second one, and when the inside is lesser or equal to 1, we get the insides to be positive, so we'll leave it as it is, 1 minus x. And when x is greater than 1, we get the insides to be negative, so you want to multiply negative to that again, so that we get a positive overall. So we just multiply by negative, so negative 1 minus x, which is just x minus 1. So we can draw our number line here with 1 and negative 1. And when you are greater than 1, you have these two. So you have x plus 1 for the first one and x minus 1 for the second one. When you are between negative 1 and 1, you have this one right here, 1 minus x. And you have this one right here, x plus 1. So x plus 1 and 1 minus x. Less than negative 1, we have negative x minus 1, and we have 1 minus x as well. So we have these three options. So the first one, negative x minus 1 minus 1 minus x equals 2. Then the second one, x plus 1 minus 1 minus x equals 2. Then the third one, x plus 1 minus x minus 1 equals 2. And obviously this is for the range x greater than 1. This is for the range x between 1 and negative 1 inclusive. And this is for the range x less than negative 1. So we start solving each one. This one, negative x minus minus x. So negative x plus x, the x's cancel out. And negative 1 minus 1, we get negative 2 equals 2, which is invalid. Then the second one, we get that x is equal to 1 after solving this, which is part of the range that we use it in. So that's one of our answers. And in this one, x minus x, so x's cancel out, and we get 1 minus minus 1, which is 2 equals 2. That means for this entire range, 2 is equal to 2. The left side is equal to the right side. That means the entire range of greater than 1 is valid as well. And obviously including the 1 as well from the previous range. That means the answer here will be valid for all x greater or equal to 1. That's the answer for D right here. So here, as you see, the entire left side is with a modulus. So remember, what we can do here is just add a plus and a minus to the 4 there, right? Because inside this modulus, we can have a -4 or a +4, and that will give us a 4 at the end. Therefore, x minus 3 over 2 minus 3x over 3 equals -4, and also x minus 3 over 2 minus 3x over 3 equals +4. Obviously, this and this you can just cancel out, and also this and this you can just cancel out. We end up getting x minus 3 over 2 minus x equals -4, and x minus 3 over 2 minus x equals +4. Then if you want to solve this, remember, you just put it into one fraction. So divide by 2, we get x minus 3 minus 2x equals -4. And again, the same thing here, x minus 3 minus 2x over 2 equals +4. With this one, we get that x is equal to 5. And with this one, we get that x is equal to -11. And that's going to be our two values of x for A. For the second one, we can do the exact same thing. So we want the inside to either be equal to -3 or to 3 to get the absolute value of it being 3. So 3 minus 3x minus 6 over 5 equals 3. And 3 minus 3x minus 6 over 5 equals -3. Here, these and these just cancel out because you can just take it to the side and subtract. So we end up getting -3x minus 6 over 5 equals 0. So we get negative, remember this is the minus, so it's applied to the whole thing. So negative of 3x minus 6 over 5 equals 0. And on this side we get negative 3x minus 6 over 5 equals -3 minus 3, which is -6. With this right here, we just get that 3x minus 6 equals 0, which gives us x equals 2. And here we get that 3x minus 6 equals 30, which gives us that x equals 12. So these are going to be our two answers, x equals 12 and x equals 2 for B. Lastly, we go on to inequalities. And the first one, we want the 3x plus 4 to be between -3 and +3. Because that way, we will get the absolute value of 3x plus 4 to be less than 3 in general, because we want the magnitude of it to be less than 3. So we wanted something like this. And then we can just solve it. And so you're solving this inequality where you subtract 4 in the middle, subtract 4 on the right, subtract 4 on the left. We get -7 less than 3x, which is less than -1. Then divide by 3 on all sides, we get -7 over 3 less than x less than -1 over 3. And those are going to be your answers. This is going to be answers. This inequality is going to be your answer. So x less than -1 over 3 and x is greater than -7 over 3. That's going to be your range of values for which this is true. For B, we're going to use a different technique. We're not going to do the negative and the positive. We're just going to square both sides because both of them are moduluses, and we can, remember, eliminate moduluses using method 3, which is squaring both sides. So if I square the left, I get 4x squared minus 4x plus 1, which is greater or equal to 9 minus 6x plus x squared. I get here 3x squared minus 4x plus 6x, which is plus 2x, plus 1 minus 9 is -8, and that's going to be greater or equal to 0. Then I can solve this. Remember how to solve this. You find the answers first. So 3x squared plus 2x minus 8. Solve this equals to 0. And we get that x1 is 4 over 3 and x2 is -2. Then we would draw our graph and how it look like. So it's going to be a U because our A is positive and our 2 points of intersection is 4 over 3 and -2. Then we are looking at greater or equal to 0. That means above this line right here, the x-axis. This is the x-axis right here. And so we're going to look at the right side and the left side. If you don't know how to do this, then you probably have missed out on something crucial in your Form 5 stuff. So you need to go back and watch my lectures of quadratics, the first topic in Pure 1, right? And so our range of answers is going to be x lesser or equal to -2 and x greater or equal to 4 over 3. And that's going to give you the solutions for this inequality right here. For the last one, I want to explain a bit more on the definition of modulus in terms of distance. So if you looked at the first one and the way we made it between -3 and +3, the reason is because we have our 3x plus 4 and the modulus tells us about the distance around it. So we want the distance around it to be less than 3. That means we want the maximum to be 3 and we want the minimum to be -3, because anything more than that, anything out of these ranges, will give us a distance away from 3x plus 4 to be more than 3, which we don't want, right? And we can use the same example here. This just means we have 5 minus 2x in the middle, and we want the distance away from it, away from that 5 minus 2x, to be less than x minus 4. So we can have the positive version, so the maximum is the positive version towards the right, and the minimum to be the negative version of that towards the left, so negative x minus 4. And that's how you would define it, because that's exactly what it means. So obviously we want 5 minus 2x to be lesser or equal to this one, maximum distance away from it, and minimum this much. And for that we can solve this. So the way we would solve this is to divide this into 2, 1 and 2, and solve these two inequalities separately. So negative x minus 4 less than or equal to 5 minus 2x, and we can solve this. We get that x is lesser or equal to 9, and we can do the second one as well, 5 minus 2x lesser or equal to x plus 4, and we get here that x is greater or equal to 1 over 3. And then we can combine these two to give us our answer. So x is greater or equal to 1 over 3, but it's less than or equal to 9. That means it lies between 1 over 3 and 9. And the way we can write this is x lesser or equal to 9, but greater or equal to 1 over 3. And that will be the range of values for which this thing right here is valid. And that completes the topic of modulus. If you want the graphical version for each of these are there in the notes section, so you can just go and check that out.